Okay, so we're on the top of page 23. Okay, and we are given our position function here. Unfortunately, it is a rational function, but we will survive. We will. Okay, so just as a quick reminder, because the steps are on the previous page, our speed function is the absolute value of velocity. Okay, and to find a max or a min, we have to take the derivative of the speed function, which looks like this. Okay, this is just a reminder of what we just talked about. So it says, let the given function be the position function of a particle moving along a coordinate line where s is in feet and t is in seconds. So in the previous problem that you guys did, there were no units, right? It didn't give you any. So here it does. So we want to find the maximum speed for the particle from time 0 to time 4. So we want the maximum speed. Okay? And then it says when during this time interval is the particle the farthest from the origin, and what is the position at that instant. So in this case, B and C, we're going to answer kind of at the same time, but I'll separate those two because the largest amount of work is for part A. So the first thing that we want to do is actually take the derivative so we can get the velocity function, right? So in order to do that, I'm actually going to rewrite the position function. So this is all for part A. I'm going to rewrite this as 100 times the quantity of t squared plus 12 to the negative first power, and this is our position. All I did was do this to make my life a little bit easier so I don't have to use a quotient rule, at least the first go round, right? What rule will I have to use, though? Yeah, I will definitely have to use a chain rule. Okay, so when you take the derivative, do I have to take the derivative of 100? No, this is just a coefficient, right? So it's going to sort of hang out there. So I'll do it in a little bit, a couple stages here. So v of t, which is really s prime of t, is negative 100 times t squared plus 12 to the negative second power. And then using the chain rule, what else am I taking the derivative of? Yeah, t squared plus 12. So that's what, 2t? So this looks like a hot mess. True?
True that.
Okay, so I am going to rewrite this so it is a little bit more user-friendly. So this would be what? Negative 200t over t squared plus 12, the quantity squared. And this is our velocity function. Okay, it looks a little bit better, but still kind of crazy. Drita, you okay?
Oh, yeah, no, I'm good. I got it.
Okay. Now, what do I do to get the speed? Okay, so really, what is the absolute value doing? What is it? Well, just all the negatives go away that are on the outside. If there was a negative on the inside, could I get rid of it? No, but there's not. Okay, so now we have the absolute value of our velocity, which is just what, 200t over t squared plus 12 squared. Everybody okay? So this is our speed. If we want max and min, we need critical numbers from the derivative. So that means we now need to take the derivative of this. Okay, in this case we just want the maximum, but we're going to take the derivative. So I'm going to do a little bit of work right here. I'm going to call the top F and the bottom G. So if F is 200t, G is the quantity of t squared plus 12 squared. Everybody know what I'm doing? Why did I do this? I do, and it's the quotient rule, right? So F prime is what? 200. G prime, we have to use the chain rule. So this is going to be 2 times this quantity, right, to the first power, times 2t. So what is that really?
4t.
Yeah, it's 4t times t squared plus 12 to the first power. Is that right? I don't have to put that 1, but I did.
Nice.
Okay. All right. So we've got the absolute value of v of t prime. So we've got f prime times g. So this is 200 times t squared plus 12 squared minus fg prime. What is that? 800t squared. Yes? 800t t squared times t squared plus 12 to the first power, and this is all over this squared. True? So this is going to be what? T squared plus 12 to the fourth power. Okay, remember, we have to get critical numbers from this, so let's try to make it a little bit simpler. Take a look at the top and take a look at, don't look at the bottom yet, but can I factor out a greatest common factor to just make my life a little bit easier? Yeah, I could. What could I take out?
T squared plus 12, 200.
Yeah, I could take out a 200 times t squared plus 12. Is that right? Okay, so we've got 200 times t squared plus 12. And then on the inside, that leaves me with what? T squared plus 12 minus, what, 4t? Is this 4t? Or 4t squared? And this is all over t squared plus 12 to the fourth power. How can I simplify this? A couple of things that I can do.
4t squared negative plus t squared.
Can I reduce this with this? Okay, so one of these will go, and this is to the third power, right? Third power. What you said combine in here? So this is negative 3t squared plus 12. Is that true? So I've got, what do I have here? Is this 200? 200 times negative 3t squared plus 12 over t squared plus 12, wow, to the third power. Okay, is that 200 going to give me a critical number? No, it's just the greatest common factor, right? So when you have a rational function and you're looking for critical numbers, remember you set the numerator equal to 0 and the denominator equal to 0. Let's talk about the denominator really quick. If I set the denominator equal to 0, meaning t squared plus 12 to the third power is equal to 0, I'll just do it right here. T squared plus 12 to the third power is equal to 0. Remember, you want to solve for your t value. So what's the first thing you would do to get rid of the cube? Take the cubed root. What's the cube root of 0? Okay, so then this is t squared plus 12 is equal to 0. Now what? Add 12?
Oh, no. T equals
But you're on the right track. T squared is equal to what? Negative 12. Okay, so can I even use, am I getting a critical number from the bottom? Okay, so it's imaginary, right? Okay, so this is kind of a done deal. So then really, after all that work, I'm only getting a critical number from the top, correct? Okay, look at your time frame from where to where. Go back to the top of the problem. From 0 to 4. Okay, so critical numbers, we've got from 0 to 4, and then I need to set this negative 3t squared plus 12 equal to 0. Subtract 12, divide by negative 3. What does it give you? T squared is equal to 4. Take the square root. Plus or minus 2. Am I going to use the negative 2? No, because time is positive, but more specifically, it's only between 0 and 4. So here, t is equal to positive 2 and negative 2, but we don't use negative 2. Does everyone understand why? Okay, so then I have another critical number of 2. Okay, there's my critical numbers. We are looking for what? After all that work, I totally forget. Oh, max. A maximum. Okay, so number line. Okay, go here. You've got 0, you've got 2, and you've got 4. Now what? Plug it in. Okay, we need to use, what do we want? Maximum speed. I'll just translate that for you. That was speed. Okay, so where am I plugging these critical numbers in?
The speed function.
That would be correct, sir. Okay, so can I plug in 1? Plug in 1. What does it give me? A positive or a negative? This is
Positive.
positive. Okay. What am I hoping this is going to be? We want to, yeah, I want it to be a negative. I'm hoping, because we want a maximum speed at time. Okay, so then what? Plug in what, 3? Am I plugging into the wrong thing? Oh, where am I supposed to be plugging in, guys? It's the maximum speed. It should be this one.
Okay.
So it would be here. Yep, whoopsie. This actually does still come out to be positive.
Oh man.
Because what happens here? This is 9, right? 3 squared is 9 times negative 3. Yeah, it's going to be negative.
Over positive. Boom.
Okay, and it only goes to 4, so am I done? Yes, this is a maximum. Okay, the maximum speed occurs at time 2, but let's go back again and let's see what they asked. What is the maximum speed? Oh, nuts. Okay, now they want the speed. So how would I find it? I need my calculator. Here's the speed function. Okay, so at time 2, you need to plug in what the maximum speed would be. So you can either plug that into y equals the whole thing, or you can just plug, because we know it occurs at 2. Agree or disagree? Yes, no?
Yes.
Okay. I'm sorry, I only see a few.
I was seeing.
Thank you. Okay, so if I plug in to the speed function, which is 200 over x, x squared is 12 squared. Let me go into the table. Okay, so here's at time 0. This is just the table, ladies. At time 0, which is one of my critical numbers, I have a speed of 0. Does that really help me? I mean, if the particle's moving at a speed of 0, it's not moving. Okay, so then the next one was at time 2, which is 25 over 16, which I have to figure out what that is. So if I have time 0, we said is 0, time 2. So can someone calculate 25 over 16 for me? And then time 4. 1.5625, I heard. And then what about at time 4? I got 1.020, because in my table it was as a fraction. It's right here, 50 over 49. So when I calculated it, it's 1 point. So does that make sense? This is, out of those, is this the maximum speed at time? Okay, so I got to go right here for A. Maximum speed at time 2 is 1.5625 what? Yep. Yeah, all that for that teeny tiny answer. It's a lot of work, right? But now the next two are going to go quick. So in part B, it says when, during the time interval from 0 to 4, so I have all kinds of numbers for that, is the particle the farthest from the origin. So if I'm asking you where the particle is, what am I asking you about? Am I asking you about acceleration, velocity, speed? Position. Okay, so I have 2 time intervals, the position at 0 and the position at 4. These are my time values, right? So go back into y equals and put your position function in there. So 100 over x squared plus 12. So this is how I did it, just like that. And now I'm going into the table. So they said at time 0, it's 25 over 3. So I'll figure out what that is in just a minute. I don't know why my calculator is doing that. And then at time 4, it's 25 over 7. Okay, so they want to know when the particle is the furthest. Well, even just by looking at that, you should be able to tell. You should. This is 8.3333 feet. This is 3.5714 feet. So it says when. What are we looking for? Time, or are we looking for feet? Time. So when is the particle the furthest? Say again? Yeah, time t equals 0 seconds. The particle is farthest, that's what it says, from the origin. Okay, and it says, what is the position? Well, didn't I already answer that? So in part C, you just say the position of the particle at time equals 0 seconds is 8.3333 feet. That's a BOGO, 2 for 1. Okay, questions? No? Everybody okay? All right, so that derivative was probably the sketchiest, the hairiest, because we got to be careful there. In example 7, this is actually going to go kind of quick, and this is a review of what you know. It says, given a position function, which I'm not moving this yet because I know some people are still writing, they give you the position function of the particle where time is greater than or equal to 0, s is in meters, and t is in seconds. So they also tell us that time is greater than or equal to 0. There's your position function. It says make a table showing the position, velocity, and acceleration to 2 decimal places. Typically in this class we go out how many? Just for clarification. 4, you're better, truncating at 4, but 3 is sufficient. Okay, but we want to probably look at 4, or whatever it says in the direction. So here it says 2. And then it says at each time in part A, determine whether the particle is stopped or the direction. So I put B here. And then we want to know if we're speeding up or slowing down, or neither. Okay, so what we want to do is go into y equals and put in this function right here. Okay, so if you have anything else in there, either get rid of it or unhighlight it. And I'm going to go into the table. So these are all my positions right here at the given time. So that means at time 1, I have 0.3679. Actually, it's set to 2 decimal places, right? So 0.37. What about time 2? I know I have the answer. I'm waiting for you. 2.2. Time 3, anybody? Thank you. 4 is 4.7, isn't it?
It's like 4.04.
I got 4.032. So it's because the directions said 1 decimal or 2 decimal places. So what is that? 2.17. So what is this? 17. This is 2. What did you say? 03. 4 is 4.69. Is that right? And then 5 is 4.21. Okay. So here I have my position. If you have in your calculator the first and second derivatives still in y equals, if you go back in here, if your function is in y sub 1, you're going to be good to go. I have to fix mine because mine's in y sub 2. So don't worry about what I have. But I'm going to turn, actually I'm going to leave that on. If I go down here, which is what you guys should have down here, if I turn these on, I don't have to do any retyping. I just need to change this. Mine's in y sub 2 for whatever reason. So now when I turn both of these on, this is my velocity, this is my acceleration, because this is first derivative, this is second derivative. So when I go back into the table, all my values are there. So this is what you should have for time 1. Is that what you have? Anybody? Right here? 1.10? Folks, you got to know how to use your calculator. Thank you. This is 1.10. So then acceleration would be 1.84. Is this right? 1.84. Okay, so what we want to do is just fill in these values, okay, given the calculator. Now, when I'm looking at the direction, okay, what am I looking at to determine the direction? Am I looking at position, velocity, acceleration, combination of the two? Yes, I'm looking at the sign of the velocity function. Okay, so right now, at time 1, are we moving left, right? We're moving to the right. What would this value have to be in order for my particle to be stopped? 0 is correct. Okay, what about speeding up or slowing down? What am I looking at to determine that? The combination of the signs, not the values, but the signs. So speeding up or slowing down?
Speeding up.
Speeding up. Okay, so I'm going to give you just a couple minutes to fill out this table. Why? Because you need to make sure you're using your calculator. So we've started to use our calculator a little bit more, which means there's probably going to be a calculator portion to the test. So for those of you that are just chilling like a villain and sitting back with your, hands behind your head, figuratively speaking, you need to know what you're doing in your calculator because it's not a partner test, and I'm not telling you. So if you do not have your first and second derivatives in your calculator, you need to make sure you put them in there. And if you don't know how to do it, you need to talk to someone in your class. You need to know what you're doing.
It's also...
I think this will the directions. I would make them laugh, but you get too focused during that.
Yes, dear.
When I put this
Go to the error. Don't just quit. Go to the error. That negative is incorrect. You have to use that negative. You can't use a minus. Oh, no. That's what it's telling me is the error. So now try it. Remember, whenever you have an error, if it says quit or go to, because it'll show you. It's not going to explicitly tell you, Kiana, you cannot use a minus for negative, but it's going to put it on top. Okay? Thank you. Sure. Someone had some crazy, I don't even know what the number was, Casio, and I was like, I don't know how to use that. I felt bad. Because I don't know how to use it. Actually, I think it was in pre-calc, so it doesn't matter. Who's still working, just so I can see? Hands. Everybody's done? Okay. Okay, so this is the table from my notes. Yes, I didn't round to 2 decimal places. You can yell at me later. But the point is, I could still get my answers. So these are your answers. Folks, you need to know what the question is asking and how you find it. I hope I went through it slow enough so that we know what we're looking for. Okay? Yes? Did I make a mistake?
No. You said you have put 0 for acceleration. It's like 3.8 times the negative 7. So how far off should we go?
What's the answer? What did it say?
3.8 times 10 to the negative 7.
Okay, 3.8 times 10 to the negative 7th is 0.6 zeros, and then it's 0.
So how far should we do it?
Just 0.
10 to the 4th, negative 4th.
If you get anything like that, my biggest thing is making sure we understand that notation, because a lot of times people will come up to me like, my calculator is broken. Okay, so that one is just clearly 0. What's happening is the calculator is using this convoluted formula that we don't have to memorize, and it is taking it out way further than what we normally would.
Okay.
0 is sufficient for me.
Okay.
Did everybody understand his question? It was actually a really good one.
Yes.
Because I don't want there to be any confusion about that. So
So like to
that's.
the -1, we should still include it? Or should we just...
Well, I don't think that it's going to say to the -1. I think the calculator will give you 0.01. But it's probably going to be something like -7th or sometimes a -4. It depends. In the table, it's going to take it out probably to the 6th or the 7th so that you can see it like that, but it's still 0. So it's about you interpreting. If you do it in the calculator and it gives you... yeah, I don't know. I'd have to look at it. I don't think there are any that are confusing like that, but I could understand that one. You just confused me, Jay. Thanks a lot.
I'm just confused.
Okay, does anyone have any questions that they